The moon's dark side. Contrary to popular belief, the moon doesn't have a permanently dark side. It goes through phases just like the illuminated side we see from Earth. However, due to a phenomenon known as tidal locking, the same side of the moon always faces us, leading to the misconception of a dark side. Today, we'll dive into the details of this mysterious phenomenon and uncover the truth about the so-called dark side of the moon. Our moon orbits around the Earth, as the Earth orbits around the Sun. These celestial bodies are in a constant dance, held together by gravitational forces. One result of these forces is that the moon's rotation period is the same as its orbital period, causing tidal locking. Tidal locking is a gravitational interaction between two celestial bodies, like the Earth and the Moon. This causes one side of the smaller body to always face the larger body, which is why we only ever see one side of the moon from our vantage point here on Earth. This synchronization is not exclusive to our lunar neighbor. In fact, tidal locking is a common occurrence in our solar system. For instance, many of Jupiter's and Saturn's moons are tidally locked to their respective planets, always showing the same face to their giant hosts. But let's get back to our moon. The side we see is known as the near side, while the hidden side is called the far side. Both sides experience day and night, just like the Earth does. As the moon orbits the Earth, sunlight illuminates different portions of its surface, creating the lunar phases we observe from our planet. The far side of the moon has been a subject of curiosity and speculation for centuries. In 1959, the Soviet Union's Luna 3 spacecraft took the first images of the far side, revealing a landscape vastly different from the near side. The far side has far fewer flat plains, called Maria, and is instead dominated by a rugged, cratered surface. Many of these craters are named after famous scientists, philosophers, and artists, such as Albert Einstein and Isaac Newton. One of the largest craters on the far side is the South Pole Aitken Basin, which stretches across 1,600 miles and is one of the oldest impact features in the solar system. The far side of the moon also has some unique features. For example, it is home to the largest impact crater in the solar system, the Aitken Basin. This massive crater stretches over 1,600 miles across the lunar surface and is a stunning reminder of the moon's violent history. In recent years, there has been renewed interest in exploring the far side of the moon. One of the main reasons is the potential for scientific research, especially in the field of radio astronomy. The far side is shielded from the radio noise generated by Earth, making it an ideal location for sensitive radio telescopes. Additionally, the far side may hold valuable resources, such as water ice and rare elements, which could be useful for future lunar missions and even manned settlements. In January 2019, China's Chang'e 4 mission made history by successfully landing on the far side of the moon, a significant step in our ongoing lunar exploration efforts. While the term dark side of the moon may evoke a sense of mystery and intrigue, it is important to remember that this term is a misnomer. The far side of the moon is not perpetually shrouded in darkness, it merely remains hidden from our view due to tidal locking. As we continue to explore and study our closest celestial neighbor, we must appreciate the beauty and complexity of both its near and far sides. With each new discovery, we gain a deeper understanding of the moon's role in our solar system and its influence on our own planet. In conclusion, the moon's so-called dark side is not a place of permanent darkness. Instead, it is a fascinating, largely unexplored region that offers unique opportunities for scientific research and future human exploration. As we continue to unravel the moon's many secrets, we are reminded of the wonders that lie just beyond our own planet, waiting to be discovered.